All right, we have one other group to talk about, and this one other group is remarkable and noteworthy for one simple fact. They don't do anything. The last group we want to talk about is the noble gases. The noble gases are the elements down here in 8A, and they're distinguished and known for their lack of reactivity. Noble gases are what are known as elements that are chemically inert. Meaning they don't react with anything under normal circumstances. Now, under extreme conditions, they're going to react with something. But under normal conditions, they're not going to react with anything. Not only that, but in their elemental forms, they're all gases. We are already familiar with a lot of these noble gases. After all, when you want to give a balloon to a kid, what do you fill it with? You fill it with helium. Why do you fill it with helium? Because helium's not going to explode. I mean, we could fill the child's balloon with hydrogen, which would actually make the balloon float a little bit better than the helium. However, hydrogen gas, as you saw from the alkali metal videos, is really, really explosive. Not a good idea to give an explosive gas to a child. Helium, on the other hand, is inert, so it's not going to react with anything. Same for neon. When we want to run electricity through a gas in order to make it glow without worrying about it exploding on us, what do we use? We use neon. When you want to do high temperature welding and you need something to heat up to a high temperature without worrying about it reacting with your metal or without worrying about it exploding on you, what do you use? You use argon. So again, your noble gases are characterized by their lack of reactivity, and they're the elements in group 8A. All right, so let's test ourselves before we wreck ourselves. All right, the first question says, identify the element described by the following. Group 7A, period 4. So we're going to go to our periodic table, and I like to do my periods first. So I'm going to find period 4. Now I'm going to find group 7A. And that gives me bromine. Let's see if the answer is bromine there. And I look, and there it is. There's bromine. All right, next question. Group 2A, period 3. So let's bring up our periodic table again. So this time I'm doing group 2A, period 3. So I'm going to go period 3. Now I'm going to look for group 2A, and it's right there, magnesium. Next question, group 5A, period 2. So we're going to be in period 2 this time. Period 2, group 5A. Nitrogen. Don't be fooled. This is one of those ones where it's really easy to forget about the first period. All right, so that's your periodic tables battleship there. Let's move on to the next question, or rather the next topic. In addition to dividing the periodic table into groups and periods, we also divide the periodic table into 3 broad categories: metals, nonmetals, and metalloids. Most periodic tables you print offline will all have a thick black line running staircase step down them. This thick black line staircase is your dividing line between metals on this side of the line and nonmetals on this side of the line. Let's take a look at a periodic table here. Alright, let's take a look at this periodic table. We see our thick black staircase step line going down it, separating metals on this side from non-metals on this side. It's really easy to keep the two straight just because of our everyday life. For example, everybody's fairly happy with the fact that copper is a metal. So if copper's on this side of the staircase line, then everything else on this side of the staircase line with copper also has to be a metal. Everybody's fairly happy with the fact that oxygen here is a non-metal, right? You'll accept the fact that oxygen is a non-metal. So everything on the same side of the line as oxygen also has to be a non-metal. Now these elements in green here, these elements in green are metalloids. Each one of these three groups has properties that are different from the other three groups. Let's take a look at them. Metals tend to be shiny and ductile. Ductile is a fancy way of saying you can draw them into a wire. Another term you'll often hear to describe metals is metals tend to be malleable. Meaning if you take a hammer and hit a chunk of a pure metal with it, the metal will generally deform as opposed to break or shatter. Metals are also good conductors of heat and electricity. Nonmetals are just the opposite. Nonmetals are dull and brittle. In their solid form, they break if you hit them. They shatter if you hit them. They're not shiny at all. And they're poor conductors. But if they're poor conductors of electricity, that means they're good insulators. Then you have metalloids. Metalloids are better conductors than nonmetals, but they're not as good a conductor as a metal. Now, the fact that metals are semiconductors makes them very important. If you go back and look at that staircase step line there, notice one of the elements that's a metalloid. Silicon, right? We said that metals are good conductors. Nonmetals are poor conductors. Well, metalloids are semiconductors, which makes them very useful for electronics. Your computer chips are made out of silicon. So you're responsible for knowing the properties of metals and nonmetals. Another couple quick things about their properties is metals, for the most part, are solids at room temperatures, whereas nonmetals can actually vary on their state at room temperature. It's learning check time! Identify each of the following elements as metals, nonmetals, or metalloids. Let's take a look at sodium. Sodium, because we haven't memorized our elemental symbols yet, sodium is represented by Na. It has an elemental symbol of Na, so that's sodium right there. Well, sodium is on the left side of the staircase step line, so since it's located on the left side of the staircase steps line, that means sodium is a metal. Then we have chlorine. Chlorine has the elemental symbol Cl, and it's located right there. Since it's an orange, that means it's a nonmetal. So we've got metal, nonmetal, silicon. Well, I just talked at great length about that. That's a it's a metalloid. silicon is. Then iron, well, that's going to be a metal, and iron has the elemental symbol Fe. It's located right there. So iron's a metal. And then carbon has the elemental symbol C, and you can see it's in orange on the right side of the staircase step line, so it's a non-metal. Chemistry's easy, life is hard, especially if Malcolm Merlin is causing difficulties in your life. Everybody write down Malcolm Merlin. Malcolm Merlin. In case you couldn't read my chicken scratch, there's the answers. Alright, let's try another learning check. Match the elements to the description. Metals in group 4A. So we're looking for group 4A here on our periodic table. So let's pull up our periodic table. We're looking at elements in group 4A. And we're looking for the metals in that group. So we go down that group, nonmetals, metalloids, metals. So we've got tin and lead. Next question asks us nonmetals in group 5A. So now we're looking right next door in group 5A, and we're wanting the nonmetals. The nonmetals are the ones on this side of the line, so that would be nitrogen and phosphorus. Metalloids in group 4A. So locate group 4A on the periodic table. But this time we're wanting the metalloids. We're wanting those elements that touch the line. Notice all the elements that touch the staircase are metalloids with one exception, and that's aluminum. I'll walk the line. All elements that touch the line are metalloids. Except aluminum. So if we're looking for metalloids in group 4A, it's going to be silicon and germanium. Let's see, are there any more practice questions for us here? Nope, that's it. Let's move on. Here are the answers in case things became cluttered for you. By the way, now would be a really good time for you to write down Speedy. Everybody write down Speedy.